Hello, dear students. Wanted to make sure that I gave you a quick little outline on how to do this inclined plane problem. I know we did it in class, but I want you to have like a little guide since we are doing this so quickly before the test. So the free body diagram should look like this for this object. Remember, you have the weight, or the force of gravity, going down, and the trick to this is that the normal force goes perpendicular to the surface of the inclined plane. Now, the way we solve this problem is that we actually split weight into a sine and cosine component. But because this is on a triangle, there's a little bit of weird trig here. So I want you to see that there are two components. And there is, in fact, a component that goes weight times the cosine and weight times the sine. But the key here is that this is the cosine of 90 minus theta. And the sine here is the sine of 90 minus theta. And I know that's a little bit weird. It's something that you need to have memorized or ready for the test. There are cosine and sine components for this problem. And in fact, when we balance components, so I'll set up my x and y here. This is the y, this is the x. Let's remember that the normal force is going to actually balance w times the sine of 90 minus theta in the y direction, and that in the x direction the equation we'll have is, and actually we can simplify this as n equals mg times the sine of 90 minus theta, and in the x direction we're going to end up getting that w times the cosine of 90 minus theta equals m times a. So apparently I need to move that over a little bit. Try to do that. Well, it's m times a. So that's going to be mg times the cosine of 90 minus theta equals m times a. This is how you need to set up these equations. And what I'll do in the next video is I'll actually do a specific example. So this is just to get you started, and then we'll do a specific example in the next video.